In this section, we will explain and discuss some of the concepts and technologies that are used by the 5G new radio to help in providing all the promised benefits of 5G. These technologies will include, for example, the use of millimeter frequency bands in 5G networks to support extreme broadband and massive machine type communication. We will also explain the use of small cells in 5G and what is the benefits of using the small cell. Also, we will be discussing the massive MIMO concept, what is the massive MIMO, and what is beamforming technique, which is used with the goal to increase the distance that the wave can travel till it reach its destination. And at the end, we will describe and explain the dynamic spectrum sharing concept, the DSS, and the use of shared frequency for dual connectivity. Here we are discussing one of the concepts and one of the technologies used in 5G networks, which is the millimeter wave. So the spectrum for 5G services is not only covering the bands below 6 GHz and including the bands currently used for 4G LTE networks, but it is also trying to extend into much higher frequency bands, which were not previously considered for mobile communications. And this is because one of the challenges for the mobile operators is the scarcity of available frequency bands for the different operators and the different countries. So the providers are moving forward and trying to check for the range of millimeter waves. So what does it mean you have millimeter wave? The millimeter waves, you mean that you are using the frequency bands in the 24 GHz to 100 GHz frequency band. And it is known as millimeter wave due to the short wavelengths that can be measured actually in millimeters. So the millimeter wave bands are critical because it will be providing multi-gigabit connectivity and extremely wide bandwidth capacity because it will be capable of supporting high bandwidths. Actually, those bands typically consist of much larger amounts of spectrum, more than the available in lower bands. So by using this wider bandwidth, the millimeter wave bands will enable the enhanced mobile broadband, the massive Internet of Things, and the ultra reliable communication, and ultra low latency connectivity for many services and devices. But there is one drawback for the millimeter waves, which is that they cannot easily travel through the buildings and can be absorbed even by the rain. That's why the 5G networks is actually moving from the traditional mobile networks towers towards the small cell concept, which we will discuss in the next slides. But with the use of millimeter waves, we are expecting to have some challenges. So some of those challenges are related to the short wavelengths of the millimeter wave. So because of this wavelengths, we can expect that there will be high propagation losses and that the signals will be blocked easily, not only by the building, but even by the human body. Also, we have some challenges related to the available spectrum for millimeter wave. We have challenges related to the supported bandwidths and how the antenna technologies can work together to deliver multiple gigabit data rates to the end user. But of course, the technology is working to have solutions for those challenges. So we can have solutions because of using new antenna technologies together with better understanding of the channel characteristics and understanding of the signal propagation scenarios. We can have solutions for all of those challenges. One of the solutions is to use the small cell size, which will be smaller and higher in density. And in case 5G will try to make use of millimeter deployments, it will be able to cover outdoor or even indoor environments. And at this time, the small cell size of the 5G millimeter wave will not only provide high throughput, but also it will allow for efficient use of a spectrum, as the frequencies can be reused over relatively small distances. So one of the technologies which is used in the 5G new radio is a dynamic spectrum sharing, or DSS. So what does dynamic spectrum sharing means? It means that the operator is using the same spectrum bands for different radio access technologies. So this will enable the 5G new radio and the LTE or the 4G to share the same frequency range, and specifically frequency range 1, which starts at 410 MHz until 7125 GHz. So the reason for using the dynamic spectrum sharing is the limited spectrum resources. And just for your idea, the license for spectrum resources come with a very high cost. So, for example, in 2017, the US received auctions of $19.8 billion for 70 MHz of spectrum in the 600 MHz band. And in 2019, it received $2.7 billion for license for millimeter wave spectrum at 24 and 28 GHz. So based on this, the vendors have positioned the dynamic spectrum sharing as a primary way to help the operators evolve their 4G networks so that it can support the 5G because of this challenge of limited spectrum resources. So, instead of having to empty a 4G spectrum band before launching the 5G, which could take years to be done, the dynamic spectrum sharing will enable the band to be used simultaneously for both 4G access and 5G access. And one of the benefits is that dynamic spectrum sharing will allow the operator to change the amount of spectrum which is used for 4G and the amount of spectrum used for 5G in the cell in a dynamic way. And this will depend on the requirements from users at any given time. So for example, when the operator is just launching 5G, they can use just a few part of the band for 5G, and the bigger part is used for 4G, and gradually it can start increasing the band allowed for the 5G and decreasing the band allowed for the 4G. So the flexibility which can be done or can be brought to the network by using the dynamic spectrum sharing will help the operator to achieve the spectrum efficiency concept, and also it will facilitate the transition from 4G to 5G over time. One of the technologies used for 5G new radio is a small cell. So what is the definition of small cell? A small cell is a base station that require minimal power, and it can be placed every 200 meters or so on. So due to the use of 5G millimeter wave, which can travel only for short distance, but of course it can provide high throughput, then the solution is to use the cells which cover small area, which is a small cell. So the outdoor cell size will be typically 100 meter to 200 meters, and the indoor high density deployment might be as small as 10 meters. So to prevent the signals from being dropped, the operators are installing many of those base stations or the small cells in a city to form a dense network, and it will act like a collectively receiving signals from other base stations and sending data to users at any location. And this will lead to improve both the coverage and the capacity of the network. So the big number of small cells will also provide subscribers with improved signal quality for more efficient data transfer. The shorter distance between radio sites also will help to improve or to overcome the short signal reach of the higher frequency 5G radio spectrum, because as we mentioned before, the millimeters can only travel for shorter distance. So the smaller cell size of the 5G millimeter wave is not only providing high throughput, but also it will allow the operators for efficient use of spectrum because the frequency can be reused over relatively small distances.